Yes, members, welcome back. Building on the previous test of goodness of fit, now we are looking at test of independence. And I remember telling you that test of independence, now we are looking at two variables. Goodness of fit was about one variable. So we looked at gender, but I want to look at ownership of computer by gender. So starting with the previous, like we did, we had created table 1. Let me call this one table 2. Tab 02, and we are going to put a table of ICT data. Then we have our gender, comma, ICT data, and we have computer, this one here. This is our table 2. And if we are to print our table 2, this is how it looks like. How many females do not have computer? There are 6. Those with computer, there are 37. Males with computers, they are 82. And males without computer, they are 15. You remember, when you total up this is supposed to give you 97 people here. And this is supposed to give you 43 we had in previous tutorial. So now, we are also going to do chi-square. Let me call it chi-square 2. And we are going to do the same thing, chi-square test of tab 02. We run it and print it chi-square 2. And here, when you run it, get the output. The Pearson's chi-square test with Yates continuous correction. And this is the chi-square value. Very funny, looking very funny. And the p-value of exactly 1, which is insignificant. What does that one tell us? That there is no relationship between gender and ownership of computer. Whether you are a male or a female, it has nothing to do with ownership of computer. That is the base R. And if you are to follow using the less R package, we have already loaded it. I'm not going to load it again, but now we are going to also let's do the bar chart. The bar chart function can as well do this. So we have gender, and then want to put by is equal to computer. And our data is ICT data, just like this, and I run this. So it gives me the same thing. Totals them by gender, and as well totals them by ownership of computer. So as we can see, they are in total, there are people who are owning computer, they are 119, and those not owning computer, they are 21. But by gender, as you can see described before. And it gives me a chi-square test of this, degree of freedom of this, and p-value of this, and plus the visual. The good thing with this is that you can as well change the visual if you are interested in it by pressing 1 by 1. And when you do that, the tables remain the same, but the visual changes. And the chi-square test of independence, it also remains the same. So let's go for the third one, the best one of using ggstatsplot. So let's use the bar chart as well. Let's say gg bar stats, and my x is equal to gender, my y. This time I have a y, which is computer, and label is equal to both. And I run that. Oh, sorry. Something is missing. Yes, data is equal to ICT data. And I run that. So it takes some time, but it's coming soon. Yes, so it brings this. If you look at something, look at this chi-square Pearson, exactly the same, 0.05. P-value 0.82, same as 0.82, only that is rounded off. Number of observations, 140, and they are not different from here. Look at this, within the no category, you have 6, 15, totaling 21, 6, 15, totaling 2, 21. Go to the yes category, you have 119, 37, and 82. It does this wonderful job. And there is something unique, sorry for the battery. You can reproduce the same thing, but varying the y and x, gg bar stats. And I can put x now is equal to computer. I put y is equal to gender. Then label is equal to both. And my data is equal to ICT data. If I run this, the same thing, I've just changed the x and y. It should give me the same thing, something looking different, but one thing that will not change is this. The p-value remains, the chi-square test remains. What changes are these numbers here? Now, the other time it was comparing by ownership of computer like this. This time it is comparing by gender. So you can see it looks at female. When you compare it with the previous, it looks at the no category, only computer, yes category. This one looks at male, female and male. 97, 97 here. And then you have your 82, which is 85%. You have your 15, which is 15% within the category of males. And this one within the category of females. But we are interested in these values, which are the same. So this is how you do it with two variables. And thank you.